This video talks about other useful things to know when you're writing R functions. So just to recap the last video where we introduced writing your own functions, we have the basic syntax here. We're saving our new function as an R object. And we talked about taking in user inputs, having default arguments, returning a named list of things back. And so what we're going to do now is just talk about other things that you should be aware of when you're doing functions and ways that you might go about, say, naming or doing if then else within a function. So let's start with naming conventions and input matching. So having a consistent naming scheme is really important, and it's actually a lot harder than you might think it is to come up with good names for things. In terms of R objects, there aren't that many restrictions on names that you give them. The main things are that they must start with a letter, and they can only have letters, numbers, underscores, and periods in their names. So usually the way to do naming is that if you have a function that you're writing, you usually want to name that function some kind of verb because it's actually doing an action. Whereas on a data object, usually you want to use a noun because it's more like a thing. It's a source of data, right? So like we have the standardize function. We're going to standardize some data. So that's a verb. We're going to do an action. Whereas we have iris. That's a data set. That's a name. That's just a noun object. So that's one naming convention that you should be aware of. Functions should be verbs. Data objects should be more noun-based. And then in terms of naming schemes themselves, so how you actually name the R objects, there are a lot of different ways out there that you might think about using. There's snake case, which is all lowercase separated by underscores. There's camel case, and then there's upper camel case. I tend to use camel case myself, although I do think that snake case might be better with the completion matching because of the underscores. It helps you jump from one letter or one word to another, but you could do periods as well. So that's another common naming scheme. So you should be aware of those. And when you're thinking about writing your functions or naming your objects, take these things into consideration. Also, whenever you're writing a function, you're going to have inputs to that function. And so there are some sort of conventional inputs that you can use. So if you have vectors, the conventional way to write those would be, say, x, y, and z for 3 different vectors. If you have a vector of weights, we tend to use a w, data frame, df, ij for indices, n for number of rows, p for number of columns. So those are kind of standard naming conventions across most functions that you're going to see in R. If you're using something that is outside of what we have written here, but you plan on using other functions from, say, some package along with your function, try to use consistent names across the functions that you're writing and the functions that you're using. And so let's just look at the inputs for the core function. Notice that they have x and y to represent their vectors. And so this easily allows us to supply these vectors here. And when people see x and y, they tend to think vectors. But notice that also we did not specify x and y exactly here. We just used first and second argument. And so R here is using what's called positional matching. So it's very important to put the most important arguments that the user needs to supply first, because those are going to be assigned based off of position a lot of times. Because people usually aren't going to name the first argument or two that they're going to give to a function. So since this is the first argument, it gets assigned to x. This is the second argument, it's going to get assigned to y. So again, when you're writing your own functions, put the most important user-specified things first. You can still do positional matching sort of out of order, if you will. So here I'm specifying that this is my x, my method is Spearman, and then I gave it another argument as well. And so it's going to go through and look for the first thing that's not filled in. So it has an x, it has a method. The next thing that it could be would be this null because that's it's not there, right? So it's looking for something else for y possibly. And so here it's using a positional match, but position based off of the first available input. Note that you can also use partial matching in your input definitions. So here, whenever I actually call my correlation function, I'm just putting MET And the only thing that matches here is method. And so it's going to use partial matching to say, well, you must mean method for that. And so we'll go ahead and do Spearman. Okay, so that's really useful to know about because a lot of times you call functions without specifying the exact inputs. Another thing to really that really comes in handy is being able to kick out of a function. And so the main way to do that for R is to use the stop function. So stop gives you a way to just kick out of that function and return something to the user. So in this case, I'm just writing a transpose function that's only going to be applied to data frames. So I'm using this is.dataframe function, which remember, we have this whole is.family of functions. So this is just doing a logical on whether or not this object that the user gave us is a data frame or not. And we're putting the exclamation point in front, which just means not. So if not a data frame, then stop and return this thing. And that will kick us out of our function. If we are a data frame, then we will go ahead and skip that if statement and we'll jump down here and return the transposed data set. So iris is that one of those built-in data frames that we've seen. So if I ran this function on iris, it transposes it because that is a data frame. But if I try to transpose as.matrix of iris, which is doing explicit coercion of iris to being a matrix, and actually take a second and think, what type of matrix is iris going to be? We have 4 numeric columns and 1 character column within our data frame. If I do as.matrix, I'm explicitly saying that everything needs to be of the same type. And so all of the columns must be converted to character in that case. So now we're saying transpose this matrix, but this will actually return true now because we no longer have a data frame. So it's going to hit this stop and kick back. So it's going to say error, and this is the stop message that it sends you. So that's really useful to know about to be able to sort of kick out whenever you don't have the right kind of input, for instance. Okay, another thing that you really quite often want to do would be sort of like if-then logic. And so you can, of course, write if-then statements within your function, but another way to do it is the switch function. And you can use this outside of functions if you want to, but switch is really useful. So I might have 2 inputs here on my function that's centering things. So vec, which should be a vector of things, and type. And type is going to represent which type of centering I want to do. So I want to do a mean subtraction, subtract off the median, or subtract off a trimmed mean. And so based off of this type, if type is equal to mean, as you see down here, then that's going to say, run this line of code. So switch, its mean is chosen, so we're gonna do vec minus mean of vec. Here I have median, and so it's going to go down here, switch, the type is median, so it's going to jump down here and say, let's do this line of code, and it will return the median subtracted off of those. And since we have the dot, dot, dot notation here, when we call the mean down here, this is actually going to allow us to do a trimmed mean. So our type is trimmed. We have dot, dot, dot for additional arguments. And so we've supplied trim, which is an additional argument to mean. And so now we've done a trimmed mean subtraction. And again, you can do the same exact logic with if else if you want to. Switch is a little bit easier to read if your conditional code is pretty short. So instead of having if do this, else do this, switch is just a little bit easier to read in some cases. And so the last sort of useful thing to know about at this point would be the idea of what is called lazy evaluation. And so R is lazy. R is not going to evaluate something unless it needs to. So for instance, if I write this function called run, that's a function that takes in x and just has the number 3. And I run and I hit and I say stop. And I actually supply the x value to be the stop function with the message stop now. If I run that, all I'm going to get out is 3. That's because nowhere in here did this function require the input from the user, so it didn't use it anywhere. It never evaluated what x was because it didn't need to. And so sometimes when you're doing, when you're writing your own functions, you want to make sure that you evaluate something that the user gave you. And so you can either just put x as one of the lines in your function, or you can more explicitly say that you're sort of evaluating that thing by writing force x. And so if I now run this function with that same argument, it's going to actually evaluate that thing that the user gave us, which is a stop function that says kick me out of this function. Another place where this comes up is whenever you're doing if statements and compound if statements in particular. So the example over here on the left, here we're storing x as a null value. And so we're doing a comparison. Is x greater than 0? Well, x isn't a number or anything. It's actually this special null value. And so R doesn't even know how to return a true or false for that. There's no way for it to say that this is true or false. You're doing sort of a nonsensical comparison. So it just says that this should be illogical, but I have nothing to give you. So it's a logical vector with nothing in it, essentially. So if you try to do an if statement with if x is greater than 0, with x being a null, this condition here is not going to evaluate to a true or false. And so it's going to say the argument is of length 0. There's nothing in there. I don't know what to do, and I'm going to kick out as an error. Okay, well, so that's fine. That might cause some issues when you do if then else kind of stuff. But there's an is.dot function for nulls. So there's an is.null function that you can use. And if you put an exclamation in front of it, this is essentially saying, are you not a null, right? So in this case, if you wanted to do this same kind of comparison, but you're not sure whether or not you're going to end up with an actual logical vector from this comparison, you could do a compound logical, as you see over here, where essentially you put the one that you know will evaluate to true or false first. So I know that this will evaluate to true or false one way or another. And if it evaluates to false, and I have an and here, R is never going to evaluate what's over here. So if this left-hand side is evaluating as false, then I know that I'm not going to execute what's in this statement because there's no way that this compound logical would be true. And so R never even evaluates this, even though it would evaluate as a logical of length 0, which would cause an error. So we're doing a lazy eval here to avoid this error that might come up. So just a couple useful things to know about if you're writing R functions.